Torch scatter. Description: torch scatter is a ptorch library function that allows you to perform efficient scatter operations on tensors. Scatter operations are used to distribute or accumulate values from one tensor into another tensor based on indices. Inputs: src, the source tensor containing the values to be scattered. The shape of this tensor should be n. Index: the index tensor specifying the indices to scatter values into the output tensor. The shape of this tensor should be n. Dim: the dimension along which to scatter the values. This is an optional argument, defaulting to 0. Out: an optional output tensor to store the result. The shape of this tensor should be m, where m is the size of the output tensor along the specified dimension. Reduce: an optional argument specifying the reduction operation to apply in case of duplicate indices. The supported reductions include sum, mean, min, max, prod, amax, amean. The default value is none, which means no reduction is applied. Outputs: output: the output tensor containing the scattered values. The shape of this tensor is m, where m is the maximum value in the index tensor. If a reduction operation is specified, the output tensor will contain the reduced values for the duplicate indices. Steps: for each value in the source tensor, the corresponding index in the index tensor is used to determine the location in the output tensor where the value will be scattered. The value is scattered into the output tensor at the specified location. If there are duplicate indices, the reduction operation is applied to the values associated with those indices. Challenges and fixes. Challenge 1: incorrect input shape for the index tensor. Sample use case that resulted in challenge 1: the index tensor has a shape that is incompatible with the shape of the source tensor. For example, the index tensor may have a shape n, while the source tensor has a shape m. Fixes to challenge 1: ensure that the index tensor has a shape that is compatible with the source tensor along the specified dimension. Challenge 2: duplicate indices without a reduction operation specified. Sample use case that resulted in challenge 2: the index tensor contains duplicate indices, and no reduction operation is specified. Fixes to challenge 2: specify a reduction operation to handle duplicate indices. For example, use sum to sum the values associated with duplicate indices, or max to take the maximum value. Challenge 3: output tensor not provided, and the default output tensor has an incorrect shape. Sample use case that resulted in challenge 3: the user does not provide an output tensor, and the default output tensor created by the scatter function has an incorrect shape. Fixes to challenge 3: provide an output tensor with the correct shape to ensure the scattered values are stored in the desired locations. Torch tensor scatter. Description: the torch tensor scatter function is a powerful tool for efficiently updating elements of a tensor based on indices and source values. It allows you to scatter values from a source tensor into a destination tensor according to specified indices. src: a tensor containing the values to be scattered into the destination tensor. It should have the same dimensionality as the output tensor. The number of elements in this tensor should match the number of unique indices in the index tensor. Index: a tensor containing indices that specify where the source values should be scattered into the destination tensor. The dimensionality of this tensor should be 1 less than the dimensionality of the destination tensor. None: the scatter function modifies the destination tensor in place, so it does not return a new tensor. Determine the dimensions of the source, index, and destination tensors. Iterate through the indices in the index tensor. For each index, retrieve the corresponding value from the src tensor. Scatter this value into the destination tensor at the location specified by the index. Mismatched tensor dimensions ensure that the dimensionality of the SRC and index tensors align with the dimensionality of the destination tensor. The index tensor should have one fewer dimension than the destination tensor. Example: if the destination tensor is a 3D tensor, the index tensor should be a 2D tensor. To fix this, you can reshape the SRC, index, or destination tensor to ensure the dimensions are consistent. Duplicate indices: if the index tensor contains duplicate indices, the corresponding values from the SRC tensor will be scattered multiple times at the same location, potentially resulting in unintended results. To resolve this, you can first sort the index tensor and then use the torch unique consecutive function to find unique indices and corresponding values from the SRC tensor. Index out of bounds: make sure that the indices in the index tensor are valid and within pay bounds of the destination tensor. Example: if the destination tensor has a dimension size of 5, an index of 6 would be out of bounds. To prevent this error, you can clip the indices using the torch clamp function to ensure they are within the valid range. Torch diagonal scatter. Description: this function performs a diagonal scatter operation on a tensor, where elements of an input tensor are scattered along the diagonal of an output tensor. Inputs: SRC, a tensor containing the values to scatter. This tensor should have the same shape as the output tensor, except for the dimension along which scattering occurs. Indices: a tensor of indices indicating the positions of the diagonal elements to be scattered. This tensor has the same shape as the output tensor's diagonal. Each element of indices represents the row and column indices of the diagonal elements in pay. Output tensor. Output: an optional tensor serving as the initial state for the output. If not provided, a new tensor of the appropriate shape is created filled with zeros. Dim: an optional integer specifying the dimension along which to scatter the elements. Defaults to 0. Dim1: an optional integer specifying the second dimension along which to scatter elements. Defaults to none. When dim1 is none, it defaults to dim. When dim1 is not none, it must be specified along with dim. Fill value: an optional scalar specifying the value to fill the output tensor with before scattering the elements. Defaults to 0. Outputs. Output: a tensor representing the scattered output. The output tensor has the same shape as the input tensor, except for the dimension along which scattering occurs. Steps: iterate over the indices of the input tensor. For each index, obtain the corresponding value from the input tensor. Place this value at the position specified by the current index in the output tensor. Repeat this process until all elements in the input tensor have been scattered. Challenges and fixes. Challenge 1: incorrect input shapes. Sample use case that resulted in challenge 1: scattering elements with an input tensor having a different shape than the output tensor. Fixes to challenge 1: ensure that the input tensor has the same shape as the output tensor, except for the dimension along which scattering occurs. Challenge 2: invalid indices. Sample use case that resulted in challenge 2: specifying indices that are out of bounds of the output tensor. Fixes to challenge 2: ensure that all indices are within the bounds of the output tensor's dimensions. Challenge 3: invalid dim and dim1 combination. Sample use case that resulted in challenge 3 providing an invalid combination of dim and dim1. Arguments. Fixes to challenge 3: ensure that the combination of dim and dim1 is valid. The dim and dim1 should specify distinct dimensions in the output tensor. Torch, select scatter. Description. The torch, select scatter function is a p-torch operation used to perform a selective scatter operation. It allows you to update specific elements of a tensor based on a set of indices. This function effectively combines the functionality of selecting elements and scattering pay. Updates. Inputs. Input 1 input tensor, the original tensor that you want to modify. This tensor will be updated with the values from the source tensor at the specified indices. Input 2 source tensor, the tensor containing the values that will be scattered into the input tensor. The size of this tensor should be compatible with the indices provided. Input 3 indices, a tensor representing the indices where the elements from the source tensor should be scattered into the input tensor. The indices should be valid and correspond to the dimensions of the input tensor. Outputs. Output 1 updated input tensor, the original input tensor after the scatter operation has been performed. This tensor will contain the updated values from the source tensor at the specified indices. Output 2 none, the function does not return a separate output tensor. Steps. Step 1 determine the shape compatibility, ensure that the shape of the source tensor and pay indices tensor are compatible with the dimensions of the input tensor. Step 2 perform selection, the input tensor is accessed using the provided indices. This creates a view of the elements at the specified locations. Step 3 scatter operation, the selected elements in the input tensor are replaced with pay corresponding values from the source tensor. The order of elements in the source tensor should match the order of the indices. Step 4 update input tensor, the changes made during the scatter operation are reflected in pay input tensor itself. No separate output tensor is created. Challenges and fixes. Challenge 1 index out of bounds, an attempt to access an element at an invalid index in the input tensor. This occurs when the indices tensor contains values that exceed the dimensions of the input tensor. Sample use case that resulted in challenge 1. Trying to update an element at index 10. 5 in a 2x5 tensor. Fixes to challenge 1. Ensure that the indices provided in the indices tensor are within the bounds of the input tensor. Validate the indices tensor before performing the scatter operation. Use appropriate error handling to catch and handle index out of bounds errors. Challenge 2 shape mismatch. The shape of the source tensor is not compatible with the selected elements in the input tensor. This happens when the source tensor has a different number of elements than the selection made by the indices. Sample use case that resulted in challenge 2. Attempting to scatter a 3x3 source tensor into a 2x2 selection from the input tensor. Fixes to challenge 2. Ensure that the shape of the source tensor matches the shape of the selected elements. Reshape or resize the source tensor to match the dimensions of the selection before performing the scatter operation. Use advanced indexing techniques or tensor operations to align the shapes if necessary. Challenge 3 data type mismatch. The data types of the input tensor and the source tensor are incompatible. This can lead to unexpected behavior or errors during the scatter operation. Sample use case that resulted in challenge 3. Trying to scatter integer values from a source tensor into a float input tensor. Fixes to challenge 3. Ensure that the data types of the input tensor and the source tensor are compatible. Convert the data types of either the source tensor or the input tensor to match before performing the scatter operation. Use explicit typecasting to ensure data type consistency. Challenge 4 missing or incorrect indices. The indices tensor is missing or does not correspond to the correct dimensions of the input tensor. This can result in unexpected behavior or errors during the scatter operation. Sample use case that resulted in challenge 4. Using indices tensor of size 2 for a 3-dimensional input tensor. Fixes to challenge 4. Ensure that the indices tensor is present and correctly represents the dimensions of the input tensor. Provide indices for all dimensions of the input tensor, even if some indices are intended to select all elements along a specific dimension. Carefully check the indices tensor for missing or incorrect values. Torch, slice, scatter. Description. The torch, slice, scatter function is a versatile tool that enables you to efficiently update a tensor based on specific slices defined by indices. It allows you to scatter the elements of a source tensor into a destination tensor according to the provided slice indices, offering a flexible and efficient way to perform operations like sparse updates, value assignments based on specific ranges, and more. Inputs. SRC. This is the source tensor containing the values that you want to scatter into the destination tensor. The source tensor should have the same dimensions as the slice indices, except for the dimension along which the scattering occurs. For example, if you are scattering along the first dimension, the source tensor will have one fewer dimension than the slice indices. Index. This tensor defines the slices within the destination tensor where the elements of the source tensor will be scattered. Each element in the index tensor represents the starting index of a slice. The index tensor must have the same number of dimensions as the destination tensor. Dim. This integer specifies the dimension along which the scattering occurs. The scattering operation applies to the specified dimension, meaning elements of the source tensor are scattered into corresponding slices along that dimension. In the destination tensor. Outputs. Out. This is the output tensor, which is the result of scattering the elements of the source tensor into the destination tensor according to the provided indices. The output tensor will have the same shape and data type as the destination tensor. Out indices. This is an optional output, which is a tensor of indices corresponding to the elements of the source tensor that were scattered into the output tensor. This can be useful for understanding which elements from the source tensor were used in the scatter operation. Steps. Determine the dimensions and shapes of the source tensor SRC, the index tensor index, and the destination tensor, which can be implicit or explicitly provided. Validate that the shapes and dimensions of the input tensors are compatible for the scatter operation. For each element in the index tensor, identify the corresponding slice in the destination tensor based on the provided dimension dim. Iterate through the elements of the source tensor and scatter each element into the corresponding slice in the destination tensor as determined by the index tensor. Return the updated destination tensor as the output, and optionally return the out indices tensor containing the indices of the scattered elements. Challenges and fixes. Challenge 1. Out of bounds indices. If any element in the index tensor falls outside the valid range of indices for the destination tensor, the behavior is undefined and may lead to errors or unexpected results. Sample use case that resulted in challenge 1. Attempting to scatter values into slices that extend beyond the bounds of the destination tensor. Fixes to challenge 1. Ensure that all elements in the index tensor are valid indices within the bounds of a destination tensor. This can be achieved by using appropriate index calculations or by checking the index values before performing the scatter operation. Challenge 2. Conflicting indices. If multiple elements in the index tensor map to the same slice in the destination tensor, the result will depend on the order of the elements in the index tensor. Later elements may overwrite values written by earlier elements. potentially leading to unintended outcomes. Sample use case that resulted in challenge 2. Providing multiple indices that point to the same slice within the destination tensor, leading to overwriting of values. Fixes to challenge 2. Ensure that the indices in the index tensor are unique or define the desired behavior in cases of overlapping indices. For example, you can use torch, unique to find unique indices, or use a specific reduction method like add to accumulate values at overlapping indices. Torch scatterad. Description. The torch scatterad function efficiently performs element-wise addition of values within a tensor. Based on a given index tensor, it accumulates the values from the input tensor into the output tensor, grouping elements with the same index. Inputs. Input 1 SRC tensor, the source tensor containing the values to be added. Input 2 index tensor, an integer tensor specifying the indices where the elements from SRC should be accumulated. The shape of index should match the leading dimensions of SRC. Input 3 out tensor. Optional, the output tensor to store the results. If not provided, a new tensor will be created. Input 4 demint. Optional, the dimension along which to scatter the elements. Defaults to the first dimension. Input 5 reduce str. Optional, the reduction operation to apply. Defaults to sum. Outputs. Output 1 out tensor, the output tensor containing the accumulated values. Steps. Step 1, the function iterates through the elements of SRC and index. Step 2, for each element in SRC, it obtains the corresponding index from index. Step 3, it accumulates the value from SRC into the specified location in out based on the index. Step 4, the accumulation is performed based on the specified reduction operation. Challenges and fixes. Challenge 1, mismatched shape between SRC and index. Sample use case that resulted in challenge 1, attempting to scatter a 2D tensor SRC with a 1D index tensor. Fixes to challenge 1, ensure that the leading dimensions of SRC match the shape of index. Challenge 2, incorrect indexing. Sample use case that resulted in challenge 2, providing invalid indices in the index tensor. Fixes to challenge 2, ensure that the indices in index are valid and within the bounds of a output tensor. Challenge 3, inconsistency in dimension along which to scatter. Sample use case that resulted in challenge 3, attempting to scatter along a dimension that is not compatible with the input tensors. Fixes to challenge 3, specify the correct dimension using the dim parameter. Challenge 4, using unsupported reduction operation. Sample use case that resulted in challenge 4, specifying an invalid reduction operation in a reduce parameter. Fixes to challenge 4, use a supported reduction operation, such as sum, mean, min, or max. Torch tensor scatterad. Description: the scatterad function performs an in-place addition of elements from a source tensor into a destination tensor based on a given index tensor. The function iterates through the source tensor's elements and adds them to the corresponding elements in the destination tensor, indexed by the index tensor. Inputs. Input 1 SRC tensor, the source tensor containing the elements to be added. Input 2 index tensor, the index tensor that determines the destination indices. It should be a tensor of integers. Input 3 demint. Optional, the dimension along which to scatter default 0. Input 4 out tensor. Optional, the output tensor. If not given, a new tensor will be created. Output 1 out tensor, the destination tensor with the scattered elements added. Step 1, the function iterates through each element of the index tensor. Step 2, for each index, It retrieves the corresponding element from the source tensor. Step 3. The retrieved element is then added to the element in the destination tensor at the index position. Challenge 1. The size of the index tensor should be compatible with the size of the source tensor along the specified dimension. Sample use case that resulted in challenge 1. If the index tensor has more elements than the source tensor along the scatter dimension, it will raise an error. Ensure that the index tensor has the same number of elements as the source tensor along the scatter dimension or less. Challenge 2. The index tensor can contain duplicate indices. In such cases, the elements from the source tensor are added to the destination tensor multiple times at the same location. Sample use case that resulted in challenge 2. If multiple indices point to the same location in the destination tensor, the elements from the source tensor corresponding to those indices will be added together and stored at that location. Fixes to challenge 2. If you want to avoid duplicates, you can use a unique index tensor or consider using a different function like scatterAdd that does not perform in-place updates. Challenge 3. The data type of the source and destination tensors must be compatible for addition. Sample use case that resulted in challenge 3. Trying to add elements of different data types, such as integers and floats, will raise an error. Fixes to challenge 3. Ensure that both the source and destination tensors have the same data type or can be implicitly converted to a compatible type. Torch scatter reduce. Description. Torch scatter reduce is a function in ptorch that aggregates elements of a tensor along specified dimensions based on indices. It combines the elements indexed by the same value in the index tensor, applying a specified reduction operation, e.g., sum, mean, max to them. This is particularly useful for operations like grouping data based on a common attribute or computing statistics over subsets of a tensor. Inputs. Input a tensor containing the data to be reduced. SRC a tensor containing the indices that specify the grouping. It's important that the indices have the same dimensionality as the input and the output tensor. It can be a tensor of integers or a list of integers. Dim optional the dimensions along which to scatter and reduce. Defaults to all dimensions if not provided. Reduce optional the reduction operation to perform. Supported operations are sum, mean, min, max, prod, amean, amax. Defaults to sum if not provided. Out optional the output tensor. If provided, it must have the correct shape. If not provided, a new tensor will be created. Outputs. Output a tensor containing the reduced values. The shape of the output tensor will be determined by the shape of the index tensor and the specified dimensions. It will contain the reduced values for each unique index in the index tensor. Steps. 1. Scattering. The function iterates through the input tensor based on the provided indices. The input values are scattered into the output tensor, with values having the same index in the index tensor being grouped together. 2. Reduction for each group of elements corresponding to the same index in the index tensor. The specified reduction operation, e.g., sum, mean, is applied. The result of the reduction is then stored in the output tensor at the corresponding index. Challenges and fixes. Challenge 1. Incorrect index dimensions. If the dimensions of the index tensor do not match the dimensions of the input and output tensors, the scatter operation will fail. This often happens when you are trying to group data along specific dimensions. Sample use case that resulted in challenge 1. You want to group elements in a 2D tensor along the Second dimension using a 1D index tensor. Fixes to challenge 1 reshape the index tensor to match the dimensions of the input and output tensors. This involves adding new dimensions to the index tensor using InSqueeze or Expand. Challenge 2 index values out of bounds if the index values in the index tensor are outside a valid range of the output tensor's dimensions. The scatter operation will result in an error. Sample use case that resulted in challenge 2. You are using indices that are larger than the size of the dimension along which you are scattering. Fixes to challenge 2 ensure that the index values are within the valid range of the output tensor's dimensions. This might involve clamping the index values using torch, clamp, or checking the index values before scattering. Challenge 3 incorrect reduction operation. Choosing the wrong reduction operation for your task can lead to inaccurate results. Sample use case that resulted in challenge 3. You want to compute the average of elements grouped by the indices, but you accidentally used the sum operation instead of the mean operation. Fixes to challenge 3. Select the appropriate reduction operation based on your specific requirement. Consider whether you need to sum, average, find the maximum, or perform other operations on the grouped elements. Torch tensor scatter reduce. Description: the scatter reduce function in ptorch is a powerful operation that allows you to combine elements of a tensor based on a set of indices. Performing a reduction operation like sum, mean, or product along the way. It's particularly useful for aggregating data from various sources into a single destination tensor. Inputs. Input 1 source tensor SRC. This is the tensor containing the values you want to scatter. Its shape can vary depending on the operation. Input 2 output tensor out. This is the tensor that will hold the reduced values. Its shape and data type should be compatible with the source tensor and the reduction operation. Input 3 index tensor index. This tensor contains the indices specifying where to scatter the elements from the source tensor into the output tensor. Its shape should be compatible with the source and output tensors. It's important to note that the indices should fall within the bounds of the output tensors. Dimensions. Input 4 reduce function reduce. This defines the reduction operation to apply to the scattered values. Common options include: sum adds the scattered values, mean averages the scattered values, product multiplies the scattered values, min finds the minimum value among scattered values, max finds the maximum value among scattered values. Output 1 output tensor out. This is the modified output tensor containing the reduced values after scattering. It's the same tensor passed as input. Steps. Step 1 scattering. The function iterates through each element in the source tensor SRC and uses the corresponding index from the index tensor to determine where to place the element in the output tensor out. Step 2 reduction for each unique index in the index tensor. The function performs the specified reduction operation reduce on the scattered elements at that index. Challenge 1 index out of bounds. If an index in the index tensor points to a location outside the bounds of the out tensor, it can lead to unexpected behavior. The result might be unexpected or even errors. Sample use case that resulted in challenge 1. Consider an index tensor with values exceeding the dimensions of the out tensor. Fixes to challenge 1 ensure that all indices in the index tensor are valid and within the bounds of the output tensor's dimensions. You can use error handling techniques to catch these issues during development. Challenge 2 incompatible shapes. If the shapes of the SRC, index, and out tensors are not compatible, the operation might fail or produce incorrect results. Sample use case that resulted in challenge to the index tensor might not have the same dimensionality as the SRC tensor or have incompatible shape with the out tensor. Fixes to challenge to carefully verify that the shapes of all input tensors are consistent and compatible with the operation. You can use techniques like reshaping or transposition to align the shapes appropriately.